Hello everyone, I am Akshita BA, Assistant Professor, Department of Civil Engineering, and today I had taken the topic Compaction of Soil from Basic Geotechnical Engineering. So first let me know the definition of compaction. As here it is given, compaction is the process of increasing the bulk density of the soil or aggregate by driving out air, right? So here in this figure you can see this is the soil which is having the pores or voids in it, right? The voids will be filled with the water and air. That phase diagram here they had given, that is solid, water and air. That means the soil contains water and air in the voids. When load is applied on this soil, air whatever it is there in the voids, that will expel out. So while doing this process, that is while applying the load, we are also spraying the water into it so that the soil becomes softer and then we can get a good density, good denser soil. So here when we are going to apply the load, the air will expel out, right? So here this is, you can see the second figure, this is the figure after compaction. So here the soil became denser, right? Air which is present here in this first figure, it has expelled out. You can see the quantity of air which is present is less now. So this is the process where we are going to apply the load, due to which air which is present in the soil voids, that will expel out. For this process we are going to spray some water so that the soil particle will become softer, and so that we can get the good denser soil, right? And then these are the some of the methods which we are going to use in the compaction, right? One is laboratory method of compaction, that is standard Proctor test and modified Proctor test. Standard Proctor test is also called as light compaction. Modified Proctor test is also called as heavy compaction. And next is field method of compaction. In that, again 5 types or maybe more than 5 it may be. So smooth wheel roller, sheep foot roller, pneumatic roller, vibratory roller, and compact rammers. So these are some of the methods which we are going to use for the compaction process in laboratory as well as in field. So let me know the mechanism of compaction. That means, as I told, there are some of the methods I am going to use, right? In that method, what is the mechanism we are going to consider so that compaction will be successful, right? Here you can see this is the graph. In x-axis we are having water content, and in y-axis we are having dry density. So when we are going to add the water content, as I told, we are going to spray the water, right? So when we are going to spray the water and then we are going to provide the load on it, then air whatever it is there in the words, it will expel out, right? So same thing here happens. When we are going to add the water content, the dry density will be more, right? So more air will be expelled out. So here the same thing happens. You can see here in this curve, when I'm going to add the water, so density go on increases. That means soil become denser up to some point. After that, when you are going to add the water into the soil, it will not, the soil will not become softer. Instead of that, what it happens, the particle of the soil which will get separate. So that what happens, more water will be there, right? So the soil will, whatever the denser soil is there, when particles separated up, that density becomes less. So here density gone decreasing up to some point, that is whenever you are going to add the water more than the some level, so the density becomes less. So where it happens, up to some point density is going to increase, right? When water content increases, up to some point density also go on increasing. So that point where you are going to take the maximum or optimum dry density and the moisture content, that is your point, we are going to take it as in y-axis, it is gamma d max, that is maximum dry density MDD, and from where we are going to get the MDD, that point in the x-axis, that we are calling it as OMC, that is optimum moisture content. So this is optimum moisture content and maximum dry density. So by this process, we are going to decide what is the water content we needed so that to get the maximum dry density. By using this, we are going to apply it in the field, right? That means up to this quantity of water you have to spray so that you can get the maximum denser soil. So this is the process or mechanism of compaction. And reasons for the shape of the curve, as I told here already, I had told the reasons, right, why the shape of curve is like this, which is increasing up to some point and again decreasing, why it is so, that also I had told, right? On dry side OMC, clay soil shows higher suction, lumps are difficult to break or compact, right? When it is fully dry, the soil is fully dry, it is very difficult to break the lumps. So what I'm going to do here I'm going to spray some water, that is increasing the water content, reducing suction, and soften the lumps and lubricates the grains for easy compaction. So when I'm going to spray the water, it will softens the soil, right? So that lubricates the grains so that we can easily get the compaction, right? And then as water content increases, lubrication also increases. Compaction results in higher density. As I told, when I'm going to increase the water content up to some point, the density also go on increasing, right? So now nearly impossible to dry out the last of the air. Further increasing the water content results in reducing the dry density. So I can remove the air up to some point, right? After that, when you are going to add the water, still air is not coming out, then what happens? This water will uh, go and stay in that uh, voids, right? So that what happens? There is a reduction in the dry density. MDD and OMC depends on the compaction energy, are not a unique soil property. And MDD and OMC depends on the compaction energy, how much compaction you are going to provide. Depending upon that, MDD and OMC will be going to study, right? And they are not unique soil property. It is not a particular property of this soil. And why compaction is needed? So compaction will increases the density. As I told, when you are going to apply the load and you are going to increase the water content, density increases. So here increase in density, to get denser soil we require compaction, right? And increase the strength characteristics. So when the soil is very denser, the soil, we can say it as a stronger one, right? So strength characteristics also increases, and when it is a stronger one, it can bear the load. So increase the load bearing capacity also, and decreases undesirable settlement. When it is having the load bearing capacity, that means any load it can bear, then there is no question of settlement also, right? And then increasing the stability of slopes and embankments. When it is not settling, that settlement is not there, when it is having the capacity to bear the load, then we can say it as the soil is a stable one. If it is a slope or embankment, the stability will be more. And decreases permeability. When there is no voids in it, so it is a denser, means what? There is less voids, right? So when there is less voids, so it will not uh, take the water into it, so the permeability is also decreases. And reduces water seepage. So when there is no water can be passed into the soil, then water seepage will be not there. So reduces swelling and shrinkage. Same thing here, water, if it is water is there, if water expels out, so swells or shrinks, right? So here it is a denser soil, it is fully packed up soil, so there will be no swelling and shrinkage problem also. And also reduces frost damage. So there is no place or there is no voids to fill the fill the voids into in the by using that ice and all, right? The ice will not filled into the void, so that there will be no frost damage also. And next is application of compaction, right? So these are the compaction process, whatever I told up to the previous slide. So where I'm going to apply these things? So now application of compaction, where I'm going to apply the compaction process. First one is compaction of foundation soil for house construction. Before constructing any house, we have to compact the soil first. If it is a softer soil or if it is a very less strength soil, then we have to compact the soil first, so that if the soil is compacted properly, then I'm going to construct the foundation and then building, then there is no problem of settlement, right? So for that purpose we have to use the compaction of foundation. Then compaction of soil, gravel or crushed rock or asphalt in road and pavement construction. In any road construction or pavement construction, we have to compact the soil first. We will be knowing that, right? One roller will be passed on the soil so that to compact, right? So here also compaction is needed. First we have to compact the soil, separate soil, and then we are going to provide some other layers on the road, and that layers also we can compact so that to get a stronger pavement. And next is compaction of soil in earth embankment. If any embankment if you are going to provide, so to uh, properly provide a stronger embankment, we have to compact the soil, right? On that embankment, whatever the soil is there, we have to compact it or pack it properly, so that there should be no failure of embankment. And then compaction of soil behind a retaining wall. If any retaining wall is there, so I'm going to construct a retaining wall, then behind that whatever the soil is there, that we have to compact it properly so that it will not fall down, so that because of that the retaining wall will not fail, right? For that we have to compact the soil behind the retaining wall. And compaction of soil backfill in trenches. If any trenches are there, then in that trenches, if any backfill soil is there, that we have to compact so that there should be no failure of that trenches also. And then in dam construction, if any dam construction if I am going to do, then we have to take or consider a stronger soil, right? So that we have to compact it and we have to provide a denser soil so that it can bear any load coming on it. And construction of clay liners for waste storage areas. So if any clay liners you have to provide in a waste storage area, then we have to use the compaction. And then ground improvement. We know that if any soil is there, we have to improve that soil characteristic, then we have to compact it properly. We can compact it by using some of the chemicals or maybe some of the waste material we can use as a additive. So we have to improve the ground property by compacting it. So for this purpose we are going to use the compaction process. And here one numerical is there in the compaction, right? One laboratory test we are going to do. We are going to get some results. By using that result, some of the things we have to calculate, that is the numericals we have. Here you can see a laboratory compaction test on soil having specific gravity 2.7. Here I am going to take specific gravity is G, capital G, right? That is 2.7. Gave a maximum dry density of 18 kilonewton per meter cube. Here the dry density, maximum dry density means what? MDD. That is in gamma we are going to say, right? So here dry density it is, that's why it is gamma D. That is 18 kilonewton per meter cube, and a water content of 15%. Here I am going to use water content of 15%, that means OMC. That means if I am going to take the dry density as 18, for which the water content it is 15% water content. So determine the degree of saturation, air content and percentage air voids at a maximum dry density. So we have to find out degree of saturation and then air content and percentage air watts at a maximum dry density which is required. So what would be the theoretical maximum dry density corresponding to 0 air void at the optimum water content? That means for 0 air void, there is no air void at all. At that point, what will be the maximum dry density that we have to find out? So these are the things to find out. What are the given data here? As I told, G they had given, that is specific gravity 2.7. Gamma D they had given, that is 18 kilonewton per meter cube, and W is given, that is 15%. So first thing we have to find out is what? Determination of void ratio. Right, first we have to find out the void ratio so that we can easily find out the degree of saturation. What is the formula to find out void ratio? Here, what are the data they given? G is given, gamma D is given, and W is given. In this thing, what you have to do is you have to take the formula gamma D is equal to G gamma W divided by 1 plus E. So here E is there, all other data we will be knowing, right? Gamma W is what? It is 9.8, right? So that is a constant value we are going to take, right? So here 18 is the gamma D, whatever they had given, is equal to G is 2.7 into gamma W is 9.8 divided by 1 plus E we have to find out. So when you are going to calculate this data, we are going to get the E value as 0.47. And next thing is to find out when E I had got, so all other data are there here, that is the formula is WG is equal to SE, right? So here I have to find out S, degree of saturation is S, W I know, G I know, and E value also I know, so that we can easily find out S value, right? So here S value I had got it as 86.2%. And next thing you have to find out is determination of air content, right? Here you can see determine the degree of saturation. Degree of saturation I have completed, and air content you have to find out. For that, the formula is air content is equal to 1 minus S, or maybe 100 minus S. 100 in percentage if you are going to take 100 minus S. If the numericals, if you are going to take decimals, then it is 1 minus S, right? So in decimal, what I'm going to get is 0.138, because S is 86.2. In decimal, if I'm going to do it, is 0.862, right? So 0.138 I'm going to get, or in percentage, if I'm going to take, it is 13.8%. And next thing is step 4, determination of percentage air voids. Here you can see, and percentage of air voids at the maximum dry density you have to find out. So percentage air voids at maximum dry density means what? Gamma D you have to consider. So for that, here is the formula, gamma D minus 1 minus Na, where Na is, I'm going to take it as a percentage air voids, and G gamma W divided by 1 plus Wg. When all the data will be knowing, only Na I'm not knowing. So Na is equal to 4.42 percentage I'm going to get, right? This is the determination of percentage air voids. Thank you.